few thousand years ago, Greeks liked to rub pieces of amber, which they called electron, together to make sparks of light, which is an early example of frictional electricity. This is the exchange of electrons being transferred from one body to the other. Subsequently, one of the objects becomes negatively charged and the other positively charged due to the imbalance of electrons. This can be called the triboelectric effect. Around the same time, somewhere in Greece, a farmer found the metal nails in his sandals to be pulled out and stuck to a rock. Yes, this was supposedly humankind's first interaction with magnetism, although back then they started calling it the rock lodestone for some reason, perhaps not realizing it was just magnetic iron ore. Turns out electricity and magnetism are kind of the same thing, although it took a while for anyone to figure it out. An early use of magnets around the Middle Ages was the compass. A magnetic needle would align itself with the magnetic field lines of the Earth, so it would always point in the same direction for the most part. A while after, in the 17th century, various people started making electrostatic generators, which is a machine that produces static electricity at a high voltage and a low current. One form of these is the Van de Graaff generator, which uses a moving belt to accumulate electric charge on a hollow metal globe on top of an insulated column. It usually consisted of a belt of rubber running over two rollers. Two metal combs acting as electrodes are at each end of the roller. One comb is connected to the sphere, and the other comb to the ground. The method of charging is based on a triboelectric effect, wherein contact causes the transfer of some electrons from one material to the other. The rubber of the belt will become negatively charged, while the upper roller will become positively charged. The belt carries away the negative charge on its inner surface, while the upper roller accumulates positive charge. The strong electric field surrounding the positive upper roller builds up and becomes strong enough to ionize air particles and transfer the charge to the upper comb in the shell. By Gauss's law, the positive charge is built up on the outside of the shell, with no electric field inside the shell. A negatively charged device can be used to create a spark from the shell caused by the transfer of electrons with high energy. It wasn't until the 19th century that scientists started making connections between electricity and magnetism. Seems obvious now, especially since I've already called it electromagnetism, but it was Hans Christian Ørsted Danish bloke who noticed that a magnetic needle was deflected by a current-carrying wire. Must have been lazy or something though, because it was actually Ampere who figured out that two parallel wires attract one another if the currents in them are flowing in the same direction, and repel each other if the currents flow in the opposite direction. This is because when the current in both wires is in the same direction, the electric fields around them are in opposite directions and cancel out between the wires, causing them to move towards each other. When the currents are in opposite directions, the field between them is in the same direction and combine to make a larger field and push the wires apart. He also found that these forces are at right angles to the direction of current. The big deal of electromagnetism was the discovery of electromagnetic induction by Michael Faraday, or Joseph Henry, who actually discovered it independently after Faraday, but I guess they didn't talk as much or something. Man, imagine that, discovering something like that only to find out that some chemist figured it out first. Must have felt like Faraday found that a change in magnetic flux enclosed by a circuit will induce an electromotive force in the circuit. In fact, the induced electromotive force in a closed circuit is equal to the rate of change of magnetic flux enclosed by the circuit. He didn't consider Newton's third law of energy conservation though, not being a physicist and all, so Heinrich Lenz had to put the negative sign on the equation and tell him the electromotive force was in the opposite direction to a change of magnetic flux. Got a whole law named after him for that, more than can be said for Henry. So now we know that both electricity and magnetism are basically the same thing and responsible for one of the four forces. The next big step is to find the connecting factors to discover the one true force. Not that one.